Before studying geometrical optics, we should at first introduce about the sign convention. And this sign convention has been taken from the NCERT book because all of you eager to appear at either NEET exam or in JEE main exam. So for both the exams, either it may be NEET or JEE main, NCERT syllabus and the books published by NCERT are most relevant and important. In case of sign convention, different books published by different publishing houses adopt different sign conventions. So one uniformity must be maintained for convenience of the students, and also that will be most convenient if you follow the book published by NCERT. So this sign convention has been taken from the book of NCERT, Geometric Optics. Now, first principle, number one, object will be placed here at this point, this space. Actually, this point is the pole of the mirror, pole. And this axis, AX, is the principal axis. This is x-axis. And this is also principal axis. Now, first and foremost, all the distances will be measured from the pole. All the distances should be measured from the pole of the mirror. In case of mirror, this will be pole, and in case of lens, this will be optic center of this lens. So here we are discussing only about the mirror, reflection of light by a curved mirror, and this is a concave mirror. You see, concave. In case of concave mirror, it may be taken as convex mirror also. So all the distances should be measured from the pole. That means this is the origin. So the point P, this is origin. Okay. Now, number two, this is object space. This is space for object. So objects should be placed at the left side of the pole. So now we are writing second principle. Objects should be placed at the left side. Okay, so this is object space. this space, this point or this point or this point or this point, this is also object space. So when object is placed here, light is considered to be emerged from this point. This is the origin of light, and light starts its journey from this point to along this direction. So this is the direction of incident light. This is the direction of incident. So this is the origin, and this is x-axis. So by convention, the light is incident. This is the direction. This is the direction of the incident light. Okay. Now, in this case, the distance, first principle, all the distances should be measured from the pole. So the distance may be along this direction or along this direction. Suppose this is the object space. So if you want to measure the distance of the object from the pole, then this will be the distance. P2, somehow this point is called sub x, or this is P. M. M is the point occupied by the object. So MP is a distance, and this distance should be taken as negative distance. So when you have to measure the distance of the object, and in case of measuring, in time of measuring, you have to go against the direction of light. Against the direction of light. This is important. The distance measured. So number 3 point. Point number 3. The distance measured in the direction opposite to the incident light is negative. Is negative. Okay. This distance is negative. Now, the distance measured in the same direction as the incident light. So, this is the negative distance. If we measure from this point to this point, that means when during measuring, we have to go from P to M and against the direction of the light. So this is negative distance. Now, if this is negative distance, then the reverse direction will be positive distance. That means along the direction of the ray, number 4 principle, the distance measured along the direction of the incident light, the distance measured along the direction of the incident light is positive. So this direction is positive direction and this direction is negative direction. Okay. Now this is all about the distances. This is all about the distances. This is origin. This is negative distance. This is positive distance. This is all about the distances. Number 5, height of the object. Suppose this is the body. This is the height of the object placed at a point that is M prime. This is the object placed at a point M prime and this is the height of the object. This height is negative height. So height downwards is negative and number 6, height upwards is positive. This height, suppose the object is placed at this point in height upwards is positive. So these are all informations about the object space very important, pole, origin. Number 3, distance negative, opposite to the direction of the incident light. Distance positive, along the direction of the incident light. And height of the object, this is positive and this is negative. So all these points should be remembered time and again during our calculation and discussion on everything related to the reflection by curved mirror. Now, another important information about this topics, and all these informations are given here according to the published by NCERT. Now this is the principal axis of the optical system we have considered, and this is the mirror. If this type of silvering, then this is a concave mirror. So this is the concave mirror. And you see, the concave mirror is a curved surface. And every curved surface should have a center. Suppose this is the curved surface and there is a center for each curve or curvature. Let us suppose this is the center of this curvature. Center. So this is the center of the curvature and this is the pole of the mirror. Okay. Now, any light that is incident on the mirror. So you know previously we have discussed this is the object space. Objects should be placed here. Any light that comes from the object space like this. So this is the light incident on the mirror which is parallel to the principal axis. We have the principal axis, this blue line is the principal axis. And this ray number 1, this is ray number 1, sorry, ray number 1 is incident on the mirror and the incident ray is parallel to the principal axis. After reflection, this ray will pass through a certain point, fixed point. Suppose this is the point, and this point is known as focus of this mirror. So, the ray we have taken here will pass to a particular point, and this point of intersection of the axis and the ray is known as focus. Okay. If we take another ray like this, ray number 2, then this ray also will pass through the focus in this manner. You have to draw all these figures with scale and pencil for smooth practicing. This ray will, after reflection, pass through the same point like this. This is the manner of reflection. Another ray, if we take, it also will pass through the same point, and that point is termed as the focus of the lens. Now, this is the case of concave mirror. If we take convex mirror, that means I am drawing the picture in another page. Suppose this is the principal axis and this is the mirror like this, and this surface is silvered. Remember, this is the pole of the mirror. This is the principal axis, x-axis. Okay, and this space is reserved for the object. Now, if light comes from any point from the object space like this, we are taking a light ray that is incident on the mirror, and the incident ray is parallel to the principal axis. This is the principal axis. After reflection, it will be reflected back in this manner. Okay. Similarly, the ray from this side will also be reflected back in this manner. Now, if we produce this line and this line in backward direction, like this. This is virtual ray. This is a virtual ray, and this is also a virtual ray. These two rays will be, these virtual rays will meet at a single point. And this point on the principal axis, it must be on the principal axis. This point is said to be the focus of this lens, this mirror. Sorry. So this is the focus of this mirror. Now any light ray that is parallel to the principal axis incident on the mirror will again we are taking a ray and another ray like this, and the manner of reflection will be like this. This is the virtual ray. Similarly, this is the virtual ray. And if we produce this virtual ray, along this direction, actually this line is a continuation of this virtual ray. Similarly, this line is a continuation of this virtual ray. That means after reflection, the rays 1, 2, 3, 4, all the rays will be scattered. That means they will diverge. And as if all the divergent rays are originating from a single point, so this is the single point, focus. This is the point. So this is the, as if all the rays are emerging from a point F. Similarly, in previous cases, if we go to analyze the previous case, so all the rays, ray number 1, ray number 2, ray number 3, and ray number 4, all the parallel rays, those are parallel to principal axis, are incident on the mirror, concave mirror, and after reflection, all the rays meet at a single point, and this point is known as the focus of this particular mirror. And in this case, all the rays, ray number 1, ray number 2, ray number 3, and ray number 4, all the rays after incident on the mirror will be scattered, and these scattered rays diverge. All the rays appear to diverge from a single point, and this point is known as focus. Now note this. In this case, object space or object distance is positive. We have considered this entire space to be object space, and the rays are coming from an extended object, suppose here. So distance should be measured from the pole. So this distance, that means object distance, is negative distance. But this is the image formed by those rays. This distance is positive distance. In case of object distance is negative and also image distance also negative. Both the distances are negative distances. Now, these all the informations given here are in according to NCERT easily, very easily available. This book is for class 12. You may download it from NCERT website, easily downloadable, and consult the book at first. And this is this discussion is section number 9.2.1, section number 9.2.1, and section number 9. These two sections has been discussed here. You may consult your textbook or NCERT book. Better to consult NCERT book that is authentic and acceptable all over India, and all the exams conducted by the government follow the syllabus of NCERT, so it will be beneficial for you. And in next video, we shall discuss about the relation between next video relation between radius of curvature and focal. Actually, the distance from the pole to focus is known as focal length. Distance from pole to focus. So you have to determine whether the focal length of a concave mirror is positive or negative. And in case of the next lens, that means whether this is positive or negative. This is the focal length. This distance is the focal length. Actually, P to F. PF is equal to F. Conventionally, focal length. PF. In this case also, PF is equal to focal. And conventionally it is termed as F. So it is either positive or negative. You have to determine it. Okay, thank you.